Welcome back everyone, this is part 4 and it's gonna be a doozy. If you've been following, there's part 1, 2 and 3 before of making my own ESP32 dev board, which is this one here. There's my little dev board there. I've been working on it for the better part of a year, and that was the version 1 prototype, which is what the last video was about getting working. And it does work, it works very well. So I'm quite happy with that. But we decided to move past it. So what we've got today is part 4 and hopefully the final product. There's probably going to be more changes. It was just going to be a riser board before, but I've decided to make it a bit more like a dev board. So that's why this version 1, when it was shown to work, became more the prototype, and version 1.1 became my new project, and it's taken a long time. Now, this video was also kindly sponsored by the awesome people at PCBWay that made this project and some other things really possible for us. I'm going to talk more on that later, but they've been super kind and you're all going to benefit from it too. So hang around to the end to find out more. Now, once this was done, or even whilst I was working on this, I actually wanted to make some changes. So I decided to go back to the drawing board a little bit and really rethink how I'd use this. Now, some of the key things on here are that it's very tiny. That was, important to me. But you could definitely do with a larger font. As you can see, you can barely read those pin numbers that are down here. The front's pretty much just as bad, so it needed a bigger font. I wanted to move this keying in a little bit in case that finger snapped off, because I figured that's too much of a hazard of liability. Having an LED on there for the status was going to be a good option. Buttons to reset it, so I don't have to do that janky crap I did in the last video. Basically where I was having to hold bits of wire on there to reset it. So buttons are always good. That does mean it'd have to be slightly bigger. If it fits, I'd love to have the CP2104 pins align with those debug pads there. So that means I'd have to be 2.45mm spaced out. The fingers should be exposed a little bit better. As you can see, the solder mask did its job, but there wasn't much track there to actually solder to. That wasn't what my design ideal was. I wouldn't do gold yet until the final product, but so be it. Definitely want a thinner PCB. This is quite thick, so that PCB was quite thick. Definitely want to thin that one out a bit. And then I realized that the C3 actually has USB built into it, so I want to add a USB port if possible, and I know that's really pushing it. And then some sort of LDO, like a AMS1117, so that I could give it 5 volts input either from the USB port or from elsewhere. I mean, realistically, it could probably even take like 12 to 36 volt input depending on what sort of LDO I use. And since it's going to be bigger, I can probably expose a few more pins. Now, this one does have nearly every IO exposed. The only one that I haven't linked to it is IO2. And the reason for that is probably because IO2 is a strapping pin. I forget though, because I don't remember why I made that design decision. But the C6, which has the same kind of soldering pattern, the C6 should work. That's a C2 and that's a C3. Now, the C6 also has more GPIOs. These little modules only have 15 GPIOs, whereas the C6, which I don't have any of here, have 22. So if I'm going to make the board a little bit bigger and still smaller than a stamp, ideally an Australian stamp, then I can put more GPIOs on there. So I got to work. As you'll see in the links below, there is now also a GitHub repo and a Hackster project, and that's because I'm trying to get more input on this. And this is version 1.1, like I said before, it might be the final product, but I don't know. Some people would have some great ideas, like some of the ideas that have gone up about an M2 connector, some sort of, battery interface for managing LiPo batteries. So there are a lot of options there. For now though, version 1.1 was meant to be the final product, and that's what I've got here as a final product for a specific use case I had that I talked about a little bit in the last episode. But these are probably going to be way more useful, and with the great help of PCBWay through your way, we're going to be able to sell some of these and even give a pile of them away. If you can see there, it says there's 52 pieces, which is insane. So, haven't opened it yet. That was loud. I've got the box, I've got the stencil. Let's open them up. And then I'll quickly thank PCBWay because they are sponsoring this project, and that is greatly appreciated. I didn't expect it. It was probably from that one Ox64 video that went mental, but they offered to sponsor it, which I think is great. I'd love to keep working with them some more because I was quite disappointed by one of the other PCB manufacturers recently, and they do really, really good product quality and communication. So grab a mouthful of this, I'll grab a knife and we'll get into that. Pardon my croaky throat too. I've just recovered from that dang chest infection that seems to be going around at the moment. It really knocked me about a bit. That was a few weeks ago now, but yeah, not fun. Alrighty, PCB way, what have you got for us? You've got a pen. Sweet, I love free pens. Is it any good? Well, it doesn't work out the box. Oh, it doesn't work on my hand out the box. That's good though, that feels like a gel pen. Gel or rollerball maybe? Alright, thank you for the pen. Stickers, PCB way 8th. I don't get it. If you get the joke, let me know. I'm clearly missing something, but stickers are always good. They'll go somewhere. Then have let's just open it up. I think I must have probably been on the beers and ordered some extra stuff. Oh yeah, because they got these beans. You get beans, whatever the hell beans are, and then you can order things like this RP2040 dev board sort of thing, RP2040 0. So similarly, it's got a status LED, it's got some little chip in the middle, you've got your push buttons, and it's got this castellations or the castellized edges, which I really quite like. So I might draw a bit of influence from this. This is similar to what I want to do. So you can see here, they've got the crystal, the chip, all the intricate components, the voltage regulator, the buttons, whatever that is. That's going to be maybe a USB-C controller or port or something, and even USB-C. So that's pretty neat. I'm going to play around with that a lot, I think. RP2040 is a good little processor. So spend money with PCBWay, earn beans, and then you get free stuff. Trying not to swear. Oh, this is just a little display that I got. It's worth a couple of bucks, little LED display. I figured that'd be handy at some point. Now, let's look at the fun stuff. What we have here is the bag of goods. See you, box. This is my riser board version 1.1, or possibly no longer even a riser board, possibly a dev board. And I don't even think I've used PCBWay before? No, I must have, surely. Woohoo! Look at these. Alrighty, so I'm going to assume there's 50 of them. Actually, no, let's quickly count them. 55, 58-ish. Count that really badly, but 58 is pretty good. That means we've got spares. So these are going to go onto my online shop to sell, but I'm going to give a pile of them away as well. I'm going to give a pile of them away with and without some C3s and C2 soldered on them too. I'm going to have a dig through my box over here and see what I've got. But let's have a look at this product up close first. So let's get real tight on that one. First and foremost, you can see they are a little bit bigger. If I grab the original one, side by side, it is a bit wider. It's about the same height though, which I'm quite happy with. Now, it's also got a lot more componentry on there. The fingers are exposed a lot better. That keying is moved. I've got a cute little PCBWay logo on there, which was a compromise we did because when I ordered 50, they hesitated. And I was like, hey, look, I'll stick your logo on it somewhere nice and fun, and we'll give a pile of them away. And they agreed. All right, so you can't read the IO numberings. That's my bad. I will have to do something about that. That's a future me problem. Now, you can see the pinholes for the USB connectors kind of poke through to the back of the SP32C3. That was not ideal, but it's kind of the best compromise I could come up with to keep it this small. Other than that though, it's looking pretty sexy. It's looking like everything that I wanted it to be. The only design problems that I had there were the font size, it looks like. Let's just see if I even made it so the CP2104 lines up with it. Oh yeah, that way around. And they are 2.54mm space. Ooh, be handy if you could see. So the pins of the CP2104 line up with those debug pads on the back. So if you really want to quickly flash it, you should in theory just be able to hold it against that. Maybe putting a bit of light tinning on there would make it easier. Sorry, that is a difficult spot to see. That should make life easier, but I mean, USB, that will make life easier. So I've got 58 of those. I might not even need that CP2104, but I have ordered a pile of them in, and like 20 or something of them in, and I will put the CP2104s on my shop if you need any, because they also do a baud rate or a bit rate of up to about 2 million, which can really help with some things like the OX64 that needs that higher baud rate. So on to thanking PCB, because I also got this stencil. And let's have a quick look at this stencil, which is packed insanely well with an extra bit of board on top so it doesn't get bent, because if we all know Australia Post, they'll fold it in half to fit it in your letterbox. And electronics don't usually like being folded in half. These boards are also very handy to have lying around though. These kind of milling backboards. Holy hell, all right. I was not expecting that. I've ordered, helps if I face the camera. I've ordered some stencils before. As you saw in the previous video, part 1 or part 2, it never came with this LE frame. That's pretty neat. So, it's glued in some way. See, I did ask them for a small one. I said it only needs to be like yay big, but they said no, it doesn't work like that. So, all right. Now I understand why. It's glued in some interesting way. It's got model number and everything embedded on there. But that, in theory, I'd have to get the alignment right. Might have to put some bracings on the back here. Should make it easier. Yeah, I'm not sure how I'm going to do this. I'll figure that one out later. But that aluminium framing is really interesting and not something I've seen before. So nice work, PCB. Now, if you are anything like me and you like to look at the fine detail, shop around, have some idea of what you want, unlike this time when I wasn't too sure because I'm not great at designing circuits, then there seems to be a lot of options out there. And that's where PCBWay stepped in for me, with a really easy to use web interface where you can upload your Gerber file and get an instant quote. There's always promotions and discounts on every month, and then they do stencils like you've just seen, along with the PCB assembly if need be. I'd rather solder it myself this time. They do CNC machining, 3D printing, large or small orders, OEM branding, part supply, pretty much anything that you want. So as part of this project, when I started chatting to them, not only did they actually engage with me on what I needed for this project and offered advice and insights, such as confirming that the design met specifications and recommending that I create a Hackster project, which is something I hadn't thought of doing. And Zoe suggested it. So thank you to Zoe, who arranged this sponsorship. Link to all of that in the description, but they also offered to sponsor this video, which is a huge bonus for me since running this channel actually costs me money. Like, I don't make money from YouTube. This is something I do for fun. So thank you to PCBWay for offering even to do that. Now, given all of this, I just had to say this thank you. I had to have a slightly longer ad read. I've put the little scrolly bar there for you to make it a little bit easier, but I wanted it to be an ad read that made sense, and so that you understood that I use them because of their quality, not just because they threw money at me. Like, I've got other income, but I appreciate quality and especially communication over anything else. They did really, really well. So there'll be a referral link in the description. I believe you get $5 off your first order. They've included these extra boards so I can give away a few blanks in this video. So let's say 10 blanks I'm going to give away, and I'll give away 4 fully assembled, and the rest I'll have on the web shop. So I'm going to use like a dozen of these in my own projects, but the rest I'll have on the web shop, link below, that you can buy. And if you want to go in the draw, just leave a comment. Comment on something productive, so either how you might improve it or how you'd use it. And then in about 2 to 3 weeks, once there's enough comments, once there's a pile of comments, hopefully, I will chuck it all into one of those online Spinometron things and draw out a random name and reach out to you and be like, hey, you had one. Now, if you want to get more later on, I will probably order more. If they sell out or if there's enough good ideas, I'll order another batch and maybe even do a part 5 or a new video about all of those. But thank you again, PCBWay, for making this project possible, for giving me enough of these that I can actually give some of them away, and for the great insight and communication ideas that really did improve what this entire project was going to be about. Now, we're going to have to assemble one. I do not know if this is going to work. It is a out of focus, complex little bit of PCB design, and it's like the 3rd ever that I've designed. So I'm going to try to put one together now with everything on it and just see what happens. I'm also going to use a LED that sinks about 40 milliamps instead of R2, I think it is, which will be the pull down on IO8 off the top of my head. So that should essentially work as a status LED. It's a 3.3 volt LED that draws 40 milliamps, which should be a pull to ground equivalent. And we'll see how that goes. I am concerned that the boot and reset pinnings I got wrong, but we'll try them too. So now, onto a montage of me messing about and trying to build one of these.
Alright folks, there you go. There is one fully assembled for you. Now, if it sounds a little bit different, looks a little bit different, it is a little bit different. For one, this is my phone recording as opposed to the production camera, so the color and everything is probably going to be a little bit different, but at least it's got autofocus. Sounds a bit different because I've got some equipment running that I just can't turn off right now, but I am on borrowed time to finish this project and show you how it works, so this is what you get. You might also notice I've got a different chip on there. So it turns out the 500 milliamp LDO that I was using just didn't work. I am apparently really dumb and didn't consider that it didn't work with the first version either. So this is an 800 milliamp now, which seems to be plenty. But you can see this is looking absolutely beautiful, especially that PCB Way logo there. Thank you, PCB Way. Now, I'm going to sell a pile of these. I can probably make about 20 of them. And sell in my online shop. I'm probably going to keep about 5, so I'll list about 15 to sell when I get back. I do have to fly away for 2 weeks. I'll put this one up to... Actually, no, I'll give this one away to someone in the comments. If you want it, let me know what you'll use it for, and anyone that has a valid use case, that something that I think would actually work, I'll chuck it into a random name draw and post you one of these. If you live in Australia, that would be even better, but if not, I'll just cover the postage. So, what we have here is the USB port, the voltage regulator, some resistors and capacitors, a blurry lens apparently, and instead of the resistor there, I have put a blue LED. Now this can result in some dicky experiences because that's on GPIO2, which is meant to be a strapping pin, but all my testing shows that it works. Now you've got the boot and reset buttons on the front. Unfortunately, you can't read the GPIO labels there, so I'll have to put those below or upload a picture. See picture here, actually, that'll explain it. Boot puts it into the flash mode, and reset resets it. So when you want to flash it, if you've corrupted it, hold boot and reset it, or hold reset whilst you plug the USB in. Now, let's get to actually flashing it, and for me, I'm going to use ESP-Home, but I also know that MicroPython and anything else that might be platform IO based will work on this too, because it is just an ESP32C3, which is a RISC-V chip, or RISC-V, I should say. Let's get on to this. The first time you plug this in, it is going to do some weird stuff. I don't know why. It could be because the LED I've got on there. I haven't actually tried it with the resistor, but you can see it's just going to keep cycling because it thinks it's being added and removed. I've tried all sorts. So if I hold the boot pin and remove it and re-add it, if I can find my USB port and then let go of the boot pin, the same behavior. It's just going to keep doing this. But you know what? It'll do that until it's flash, and it works anyway. Even if we go and have a look here at ESP tool, it picks it up perfectly fine. So I think this is just some cautious debug mode it's in. What we'll do now is we'll go over to ESP-Home. We'll hit new device, C3 version 1.1 test. Let's just go connect. See if it wants to grab that one. I might need to put it in boot mode for this, but it's detected it and it's preparing a installation. We'll give that a moment here. Alright, there we go. So in theory, it's erasing the chip to start with. Now, I don't think I've specifically put it in any specific mode for this, so it's just catching on a reboot loop and doing what it needs to do. Now it's installing, that's a good sign. This is further than I got the first 100 or so times dealing with this LDO. That was a bit too small. Now, it is going to fail to find this device on the network. The reason being that my network doesn't support MDNS. So it's not going to discover it automatically using the local host name. That's for a huge variety of reasons, but we won't get into that now. What we're going to do is refresh the page, have logs plugged into this computer, and we're not going to see anything. That's all we get. If you go reset device, it is booting successfully. I know that for a fact. Something important to look at here is it's in DIO mode, not QIO mode, but this is booting. The issue is that the output is on the UART pins, which would go to serial. We want to use the USB-CDC for this. Now, the issue with doing that is if we go to add it, it's going to fail straight away because this defaults to the Arduino framework. That's not going to work for us. So let's go and grab some code that I already put together earlier. I'm going to upload 2 versions of this. I do have the Arduino framework version where I've put in a whole pile of things such as the API, so I can talk to ESP-Home over their updates, logging the web server, allowing your Bluetooth pairing, disabling MDNS for my sake anyway, just to save on that bit of memory because I don't need it. Pre-adding Wi-Fi, I've got 2 Wi-Fi networks, hence the weird thingos, and a captive portal in case it can't join your Wi-Fi. All very handy. However, if we look at the one that has the ESP IDF, we have to go a little bit further. So first of all, we have to specify that we're flashing it with DIO mode. Down here, specify the ESP IDF. What I've done is I have added, you can do this in both actually, I've added this little light for the status LED so we can tell it's booted. Standard things, API and OTA. I've then added this USB serial JTAG. Sorry if I got CDC wrong before, but I'm tired. This hardware UART so we can actually see what's going on. And everything else is the same, except I added a static IP here just so we can see that it actually comes online. Alright, so what we're going to do here is hit new device, we'll go C3 version 1.1 test with USB logging. We'll skip this step instead of the auto detect, we won't use the recommended settings, we're just going to go, yep, that's fine. Skip that bit as well. And we'll paste in nearly everything. We won't override that bit at the top though, just because it does get a little bit sad. So, get rid of that. It can get confused basically about what the device is and what's going on. So if we hit save, install, plugged in, connect, and it's preparing the installation. It already knows how to talk to this device because it's already got ESP-Home on there. We've got enough RAM that we can do over-the-air updates anyway, which is I think 2 meg flash minimum. However, the issue that we've got with that is I don't have MDNS, so that other device, which we can have a look at here, never actually showed up as online, even though it's online. We have overcome that with specifying the static IP this time, and we have also overcome the fact that we can't see it boot by specifying the hardware UART or the USB UART. So this is just compiling that code now. It can take a hot minute. If you're running this on a Raspberry Pi, it can take a very hot minute. I'm running this on a virtual machine on this laptop, so it's a little bit quicker for me, maybe a couple of minutes. I do wish that Home Assistant, ESP-Home I should say, would still show you the progress here. I like to know that something was actually happening and that this isn't just getting like a 522 error or something in the background and sitting there forever. So if you could bring that back or set it as an option, that'd be great, but I know this is working too. Again, because I spent so many hours trying to make this bloody thing work, not realizing it was the LDO. I should just buy an oscilloscope. If someone wants to donate me any oscilloscope, I would have been able to see the voltage drop. What I ended up doing was that same janky shit as before and just stuck an AMS 1117 on there. And this one, you know, it's got a fair bit of current, but of course it doesn't fit that size. So I ordered a pile of other ones until I found what, is that right? Yeah, I ordered a pile of other different capacity. And ultimately, what I tried first was the 800 milliamp, that's not even that, that's a bloody capacitor. There we go. The 800 milliamp ones from LCSC, because they're actually the cheapest. So I was just kind of hoping that the cheapest one, which I got a roll of 150 of, worked. And you know what? It bloody did. So thank you. I've also just got to say thank you for PCBWay. They've been incredibly patient with this. I've taken my sweet time, as I do with everything. But there's been so many hurdles with having to go away for family stuff, like having to travel. There's been other work stuff that's come up. And then of course this didn't work and I had to order more parts and it's just a hassle. So thank you to them for their patience. Thank you for allowing me to give away a pile of these. And I look forward to working with them again. Their communication's been excellent. I've dealt with some other PCB manufacturers on general projects, not even sponsorship where I'm essentially working for them. And they aren't as friendly as these guys and girls and whatever they want to identify as. So that's been good. All right. It's finished compiling it. It also had to download all the Espressif IDF there and unpack it all. Then it's compiled it. Now it's installed it, which is nice and quick. And it should tell it to reboot straight away. Let's see if we get any good status. I made a mistake that I even talked about not making, which is the bloody flash mode. I said I wouldn't override this bit, but we do need, MOAD. We do need that line. That's a pain in the ass, but at least it'll be quick to install this time. So confused then. I just thought that was going to work straight away. But my own oversight, my own rushing, as always. Oh, there we go. Jesus Christ, that took forever. I guess flashing in different modes, it is actually doing a lot different. I probably had to recompile the entire thing for some reason. So in theory, this should flash and that should start blinking. Yes! That's what we want. That's what we wanted to see happen. So we close this. Blinking means something's not right, but that is exactly what we expect to see, and so is that online. Now, if the second we hit logs, that's going to stop blinking. Well, the second I hit wirelessly. The reason is that for whatever reason, it blinks if there's no API connection. So if you take that API line out, it's not going to blink because everything's perfectly fine. But we can see here that it has worked perfectly. It's warned me about that strapping pin, but who cares? It works. It's joined by Wi-Fi. It's got great signal. Everything would have helped if I fixed that replacement. Looks like it's working perfectly. This is the ESP32C3 version 1.1 riser board. I mean, I could even argue that it might be an ESB-C. You've got nearly all input-output functions. What I'd love to do is have a version of this that can actually take an SD card. Don't know where the hell I'd fit it, but maybe across the top headers there. And then see if I can get Linux working. If anyone wants to do it for me, that'd be great, but you can theoretically run Linux on this ESP32C3. Everything it needs is theoretically there. So future project for me. We could try putting MicroPython on this, but I don't really see the point. We know it's going to work. We know that this project works. Now, people have also been asking what the pin structure is for and how and why that works. Now, the idea is that if you've got a PCB, you cut a slot in it and you can mount it that way in the slot. You could theoretically also just make a header connector to that. Now, look. There's a lot of different options and I've got a few ideas. This is version 1.1 and I am probably going to do a version 1.2 now because, again, doing this, I've come up with so many new ideas. So I'd love to have C6 compatibility. Now, the ESP32C6, which is only just becoming available, has different pins. They're not on 18 and 19 for the USB connection. So I might need to use some 0 ohm resistors that you set based on which you want to use. With that, I'd also love to move this to USB-C, so we've got some more functionality there. It still might only be 2.0 mode, but everything's USB-C, and I feel like that's the right way to go. With that, the C6 would also have 7 more GPIOs from memory. It goes from 15 to 22, so we might need to make this board a little bit wider, but we do still have room there within our current form factor. We could possibly, somewhere right where my face is, cram on a small 2-pin connector for lithium-ion battery and put a DW01 regulator, I forget what they're called, on there. Separate the status LED out if we find that that is causing problems, being a strapping pin, of course. And finally, move to the gold-plated and castellations of these edge connectors. So we look here again at my current favorite, the good old Milk-V Duo. These edge connectors I love. Now, this is so it can mount flat on a surface. It has nothing underneath, and mine can't do that. But these castellized edges means you can have an edge connection, or you can have a header pins on it done properly, not like I have there. Or you do have the option like this to still just kind of mount it horizontally or vertically. I like that idea. I'm probably going to go to that, and a lot of people have suggested it. So for now, I'd absolutely love your input. I'm going to put the links below to the code, to the GitHub repo, to the Hackster project, everything like that where you can contribute. Feel free to leave any thoughts below as well. YouTube loves comments, of course, so I'm going to try to reply to everyone. And this is a passion project for me. This is a passion project that, besides the lovely folks at PCBWay sponsoring these ones, I've been doing for nearly a year just because I want it for me. And again, inspired by ESPHome. So I think I'll give 10 blank boards away, and then 1 with the C2 module, 1 with the C3 module, just randomly drawn, and I'll do a little short video or something when I do. This one specifically, as I said, leave a comment below with what you'd use it for, and I'll just give this one away separately as well. I'm going to go away for 2 weeks, but I'll leave this packaged up at home for the missus to just ship wherever it needs to go if I like any of your comments. Like, if someone puts a comment idea up that is just excellent, just have it. I won't even wait 2 weeks. I'll just send it to you. I'm glad, though. I'm really glad. It's been a long time coming. It's been a lot of money put into this. I want it to be a community project, though. I'd love your help getting Linux on it. If anyone knows how to, where to even begin, I know nothing about build route or those different options, so your support would be appreciated. But this has been a learning curve for me, and all the input I've had so far has been greatly appreciated from the community and abroad. So keep up the great work. Espressif, you make some of the best chips out there. You have a full SDK. You contribute to the community. That is greatly appreciated compared to so many of the others like T-Head and Buffalo, which are kind of under embargoes, I guess. Thanks again to PCBWay and everyone that's watching this and helping me apparently actually make a successful YouTube channel one day. So don't forget to like and subscribe so that the algorithm decides to give me more money or show this video to more people and give me more money. And I'm going to start designing a smart socket similar to the Atom based on this, because this is what I wanted. This is the final product for me. Anything past this is going to be for you guys or just to keep learning. Till then, take it easy, enjoy the end of whatever the hell season it is there when this gets out, and stay safe.